Hello dear students. So as a part of the second unit of our syllabus, now we are going to study the next topic, that is called reflection by a single spherical surface. So in the previous video we have studied refraction. Now we are going to study reflection. Okay, for that we will be drawing one diagram, okay, ray diagram. So for that we have simply reflection means we need to have a spherical surface, that is a mirror. Okay, so we will just draw like this. So shaded means it is mirror, it doesn't allow the light to pass through it. Okay, so this is the thing. And then we have our optical axis, okay, or principal axis. And suppose that this is the object position, and the ray of light is going out like this, and this is the point of incidence. Okay, so this point of incidence I will name as S. Okay, and this point I will name as P. Okay, and I will just draw some marking line for this point P. Okay, fine. So ray of light is incident like that. Okay, and after falling on this it will come back and it will be bounced back, that means it will be reflected. Okay, so it will be reflected and it will come here, and this is the image position, and obviously this is the normal. Okay, this is a normal drawn at the point of incidence, and this point is nothing but the center of curvature. Okay, and I will name this angle, this is called alpha 1. Okay, I will name this angle, incidence angle, as phi 1, this is phi 2. Okay, and this angle as beta. Okay, and I will drop a normal from the point S on the principal axis, and I will name this point as D, and this height is H. Okay, now object distance is X. Okay, then center of curvature is at a distance small r. Okay, and image distance, that is called, obviously as we have used in the last video, it is y. Okay, and yeah, that's all about the diagram that we are supposed to concentrate. Now what we are going to do in this diagram, so you can consider that in the parallel approximation, all these things are in parallel approximation. So from the diagram you can see that phi 1, if I consider phi 1, so again let me do it again. So can I write phi 1 plus alpha 1 equal to beta? May I write like that? If I consider the triangle OCS. Okay, so simply phi 1 will be beta minus alpha 1. So let it be our equation number 1. Okay, and then if I want to get phi 2, okay, for that I will consider the triangle CIS. Okay, CIS. So there, what will be that issue? So phi 2 phi 2 plus beta, phi 2 plus beta equal to alpha 1. Sorry, one thing that I have missed here, this is alpha 2. Okay, so the triangle CIS, if I want to like that, then it will be phi 2 plus beta is equal to alpha 2. So if I want to get phi 2, will it be alpha 2 minus beta? So this is our equation number 2. Okay, so let me write down the equations very nicely. So first thing that we have got phi 1 equal to beta minus alpha 1, that is equation number 1, and phi 2 equal to alpha 2 minus beta, that is our equation number 2. Okay, so let me remove all this. We will do other rough work whenever required here. and where we will need representation with along with the diagram. Okay, so let me keep this area clean. Now these two things we have. Okay, now we will be following the same rules that we have done under paraxial approximation. You remember, under paraxial approximation what we did, that sine phi 1 is nothing but tan phi 1 is equal to phi 1. Similarly, sine phi 2 is approximately equal to tan phi 2 is approximately equal to phi 2. Sine alpha 1 approximately equal to tan alpha 1 approximately equal to alpha 1. Sine alpha 2 approximately equal to tan alpha 2 approximately equal to alpha 2. Similarly, sine beta approximately equal to tan beta approximately equal to beta. So these are the things that we need to take into consideration. All right. So here also we will apply the same rules here. So I will write it as so phi 1 is nothing but tan beta minus tan alpha 1. So this is equation number 1 implies. So tan beta, let us find out what is tan beta here. Look at the diagram, tan beta. So if I take the triangle SCD, okay, SCD, tan beta is nothing but h by r, because h is the perpendicular, r is the base. Okay, similarly, tan alpha 1, if I consider the triangle, so tan alpha 1 will be equal to again h by x, and tan alpha 2 will be equal to h by y. So we will be writing like this. This is h by r minus h by x. So 2 implies phi 2 equal to tan alpha 2 minus tan beta. So that will be equation number 3. So it will be h by y minus h by r. Okay, so this is phi 2. So that will be equation number 4. But you know that as per the laws of reflection, angle of incidence is equal to angle of reflection. So if we go back to the diagram, what is the angle of incidence? Phi 1. What is the angle of reflection? Phi 2. So phi 1 equal to phi 2. So what is phi 1? From equation 3, h by r minus h by x. H by r minus h by x. And what is phi 2? H by y minus h by r. H by y minus h by r. So what we can do, h by r, we can bring this to this side. Okay, so it is h by r, so it will be h by y plus h by x. H everywhere, so we can simply cancel them. So it will be 2 by r equal to 1 by x plus 1 by y. So this is what we wanted to obtain for but again using sign convention. Okay, let's go back to the diagram. So yes, now it is time to remove all this. This is not required. We have done what we was supposed to use here. Okay, so look at x. So x is the object distance. So object distance, it is placed. So according to sign convention, anything that on the right is positive and anything that on the left is negative. All right. So x is basically a negative quantity. Similarly, y is also calculated here. That is also a negative quantity. and r is also calculated here, so that is also a negative quantity. All right, so what is that negative quantity? I will show you. So x is object distance, so it is noted by u. Since it is on the left side, it will be minus u. Y is the image distance, it is noted by v, and that is, since it is on the left side, it will be noted by negative. Similarly, it is radius of curvature, that is also negative. So all are negative here. So using sign convention, 2 by minus r, 1 by minus u plus 1 by minus v. So what remains? 1 by u plus 1 by v equal to 2 by r. So I hope this is very familiar to you, which is the general formula for the so if I write like this, so r is nothing but twice f, focal length. So 1 by u equal to 1 by v is nothing but 1 by f. So this equation is very familiar with you, isn't it? So in exam you may be asked to derive this equation or this equation for lens or for mirror. So then you will have to follow this method. Okay, so that's all for the second topic, that is reflection by a spherical surface, and you are free to ask discuss your doubts if you have any through WhatsApp as well as in Google Classroom. So let me know if you are having any doubts regarding this derivation.